Question number 3. Explain why there is a general increase in the fast ionization energies of the element in period 3 of the periodic table from left to right. This was a Kcse question that was done in 2007. It was in paper 1, number 8, 2 marks. So there is two terms that we are supposed to define before we tackle this question. If we are in a position to define these two terms, we will be in a good position to answer the question effectively. First, as a student, you must know what is ionization energy. Ionization energy is the minimum amount of energy required by an atom to lose an electron in gaseous state. So if we talk about fast ionization energy, we are just talking about the energy that is used to remove the first electron. That one we call it fast ionization energy. We have something called period. How do you define period? Period, these are elements that are grouped. These are the elements having the same number of energy level grouped together. So when we have elements with the same energy level, we call them period. So we have period 1, period 2, period 3. So if you talk about period 3, meaning these elements have 3 energy level. A good example, we have sodium, we have magnesium, we have aluminium across that period. Now our question is why there is an increase in the ionization energy across the period. I will answer that question effectively. So across the period, there is an increase in number of protons. There is an increase in number of protons. As the number of protons increases across the period, there will be an increase in nuclear charge. As the nuclear charge increases, it will pull the outermost energy level towards the nucleus. Therefore, the atomic radius reduces across the period. So, that's why the ionization energy decreases, because if the atomic radius is so small, meaning that the outermost electrons are strongly held to the nucleus, and compared to the one with the large atomic radius. When this one has a large atomic radius, meaning the outermost electron is loosely attracted, so it is easier for us to remove this electron, and it will require less amount of energy to remove this electron. But when the atomic radius is so small, meaning the electron is strongly held to the nucleus, hence high amount of energy will be required to remove this